So here's the UPC code quiz, and I will show you how I do with that. I start by taking these numbers and recopying them. And there's an empty one, which we've been calling X. And then we have what we call the weights, which is 3, 1, 3, 1 alternating. Remember, if we have a non-American UPC, it starts with 1, 3, 1, 3, but that doesn't matter because we're only going to do this one for the exam. Okay, now what we're going to do is we're going to multiply. For example, 3 times 9 is 27, but since everything's going to be mod 10, then we're not going to worry about it. So the formula for finding the checksum digit is you have to weight these guys by 3, 1, 3, 1, 3, 1, 3, 1, multiply them, add them up, and they all have to be equal to 0 mod 10. Okay, so since it's mod 10, that's very convenient because we can just throw away everything except the last digit. 5 times 1 is 5, 3 times 8 is 24, 3 times 3 is 9, 3 times 8 is 24. This guy we're just going to call 3x. Okay, no big deal. Now, what I'm going to do is, since I'm going to mod by 10 anyway, I'm just going to can anything that's a 10. But we did not get very lucky on this one because normally we have more matchups than this. We have a lot of 9s and 7s here, so unfortunately there's not that much that we can do. Sometimes we can do like a 5, a 2, and a 3 and cancel that together, but I don't see any other convenient things we can cancel. However, we have a whole bunch of 7s. I'm just going to get rid of those together. 7 times 4 is 28, so those 7s together are going to become an 8. And let's see, we have, oh, we do have a 10. We have a 4, 4, 2. That's a 10, so we got rid of it. And what do we have? We have 5 plus 9. Okay, 5 plus 9 is 14. So I can get rid of them together and turn it into a 4. And so I've gotten rid of everything that's crossed out or underlined. And that simplifies our life considerably. What's 8 plus 4 is 12, so we have 2 plus 3x is equal to 0 mod 10. For those guys who love your calculators, you can do it this way. You just pull out your calculator and you could have just done 7 plus 5 plus 4 plus whatever, 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 and you'd end up with something like 82. Let's say you end up with an 82. Then you would just chop off the 8 and keep the 2. So you can either do it by calculator, or you can do it by hand, but the 3x remains. Now what do? Well, now there's two ways to proceed. You can either try every single x possible, and there's only 10 of them, until you find the one that works, or you can use the magic 7 trick. The magic 7 trick is because 3 times 7 is 21, which is equal to 1 mod 10. So 7 is the magic thing you multiply 3 by to make the 3 go away. So the way we do this outside of mod 10, we would do 3 times 1/3 equals 1. So 1/7. 7 is kind of like 1/3 is. 7 in mod 10 is the multiplicative inverse. In mod 10, the way 1/3 is the multiplicative inverse in our normal world. Okay, so we go ahead and multiply both sides by 7, but 7 times 0 is still 0. Okay, so we distributively multiply, we get 14, keep the 4. Alright, now we're home free. Okay, so the x is just going to be 6. Alright, so what about if we get an easier problem? Let's look for an easier problem. Alright, so we have, let's see, I need something to write on here. Okay, so I have 5, 8, 9, 4, 0, 7, 9, 7, 0, something, 8, 5, and the weights are 3, 1, 3, 1, 3, 1, 3, 1, 3, 1. Beautiful. 3, 1. Yeah, I did that on purpose. Okay, so 3 times 5 is 15, 3 times 9 is 27. And that one's much easier, right? So maybe we even have groups of 10 that we can get rid of much more easily than we did before. but that's about it. Okay, so we have 7, 7, 7. Ooh, that's a 1. Cool. 4 plus 4 is 8. Okay. 4 plus 4 is 8. Plus x is equal to 0. 9 plus x is equal to 0 mod 10. So x should just be 1. So we come over here and click the 1 button, and that means I messed up. Great. So let's see how I messed up. 5, 8, 9, 4, 0, 7, 9, 7, 0, something 8, 5. And I go 3, 1, 3, 1, 3, 1, 3, 1, 3, 1, 3, 1. Okay, 3 times 5 is 15. Check my work. 3 times 9 is 27. 3 times 9 is, oh, this should be a 7. That was bad. Whoops. So I should add 5 to everything. Or another way, so I should add 5, 5. If that's my only error, then let's see if that works. This should become a 4 plus x is equal to 0 mod 10, so x should equal 6 again. I didn't want it to be 6. Okay, we're right. So unfortunately, you do not have a computer to check your work on, and if you are doing this live, like in the exam, you won't know. And so here's some little hope for you. Let's say you made the same mistake I did. That would be pretty lenient, because what happened was you showed all your work. You showed that you were using the standard procedure I showed you, and I would say, oh, look, 3 times 9 is not 27. You have to drop the 2, not the 7. But I could see what you did, and I could see that your work flowed, and that your error, and that your answer was a direct result of that specific error. So in that case, your work would receive most of the credit. But if you didn't show me any work, and you just said, like, x equals 4, you would get no credit. If you just said x equals 6, you would get no credit. Okay, so you can't just give me no work. You have to show your work, and your work will get you out of your clerical errors and get you some partial credit, some pretty generous extra credit. The better you can do at documenting your steps and making your work clean, then the more likely you are to get partial credit.